Can you see my slide?
Yes, ma'am.
Okay. So this in the morning we studied about this architecture diagram of bus interconnection scheme. So each and every lines we are going to study in the coming slide. Okay. So first we are going to study about what is system bus. We all know what is system bus. It is a major component of a computer. Then the most common computer interconnection structure, basically common interconnection structure, we call it as the system bus. Okay. It has 50 to hundreds of separate lines. Each lines have particular meaning or function. Okay, there are 3 lines, major lines. It is classified into 3 functional group, that is data line, address line, and control line. Okay. Additional to this, there will be a power line also. The last sentence using addition to this, there's a power distribution line. First, we are going to study about the data line. See, data line, it provides path for moving a data from one system module to another system module. Okay, so these lines are collectively called, the line collectively we are calling as data bus. It can also called as data bus. Okay, so the data bus, it consists of, already I told, 32 separate lines, 64 lines, 128 lines. Okay, so at a time it can send 32 signals or even more separate lines we can have. So the lines increases, the capacity of the performance of the system also increases. Okay, the number of lines being transferred referred as the width of the data. This 32 width, 64 width, 128 width, we can call the number of lines as a width of the data bus. Each line can carry only 1 bit at a time. I have already mentioned this in morning class. Each line can send only 1 with the 0 or 1. Okay. The number of lines determines how many bit can be transferred. The number of lines, this is the number of lines. At a time, how many bit it can transfer. If it has 32 lines, at a time it can transfer 32 bits, 64 bits, 128 bits. So number of lines determines how many bits can be transferred at a time. Okay. The width of the data bus determines the, I already told this, note this point, width of the data bus determines the overall performance of the system. Okay. If the bit is 32-bit wide and instruction is 64-bit long, the processor must access M by Y twice during each instruction cycle. Memory, okay. So next is the address line. Address line, it is used to designate the source or, so address line, you know, what it carries. It carries the source or destination, the address. Address line carries the source or the destination address. Okay, used to designate the source or destination of the data. Source and destination address of the data on the data bus. Okay, so if processor wish to read a word 8, 16-bit or 32 bits of data from memory, then it puts the address of the desired word in the address line. Say data, this processor is wishing to read a word. It may be 8-bit, 16-bit or 32-bit data. Data will be transferred through the data bus and the corresponding address will be put in the address line. Okay. The width of the address line determines the maximum capacity, memory capacity, the maximum possible memory capacity of the system. So the width of the address, it determines the maximum possible memory capacity of the system. Okay, address lines generally used to address the I/O port also. Address line generally used to, so I said for each and every input and output port, there are different, they also have unique address. Okay. So that particular address line is generally used to address the I/O port also. Control line, it is used to control, you know, a control line, it is a signal which controls overall performance of the system. See, used to control the access, the use of data and address lines. Okay. The data and address lines are shared by all the components. So to monitor their uses, the control lines also send along with them. Okay, control lines transmit both command and timing information for during the transfer. Okay, so timing signals indicate the validity of the data and address information. It indicates the validity, how much, so which time it is valid, the data and address that it is given by the timing signal. Command signal specifies the operation to be performed. Command, you know, add, subtraction, multiplication, the operation to be performed specifies the operation to be performed. Okay. So the control lines, what are the things it includes? See, memory, right? So these are the things which is included with the control lines. What are the things it passes as a control signal? Memory, read, write, memory, write, read, IO, write, read, then transfer acknowledgement. Transfer acknowledgement means if a processor receives a read command, then it acknowledges that I have received it. Okay, that is. Then bus request, bus grant, interrupt request, interrupt acknowledgement, clock reset. These things are sent as a control. These things are sent as a control signals through the control line. Okay. So what are the things? Memory read write, input output read write, transfer of the acknowledgement, bus request. This I will next slide. Detail I will take about this. Okay, bus request, bus grant, interrupt request, interrupt acknowledgement, clock, and reset. So these are the things which are sent as a control signals to the control line. So before going into this topic, point-to-point interface, we have to study another one slide. Are you clear with these topics? Can you acknowledge me through message? Are you okay?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So next we are going to study another one thing, that is bus arbitration. Okay. So you all know now what is bus, system bus. So system bus, it has three components. What are the three components? Can you say? System bus. Data line, address line, control line. So how this can be communicated, how this data can be transferred to the system bus, everything we can see using this bus arbitration. Okay. So bus arbitration means what? Means managing the system bus. Who is taking control of the system bus? That is the main thing we have, because multiple devices are there. So we already studied in a slide the architecture of bus. System bus. So it is connected to CPU, it is connected to IO devices, it is connected to memory. So multiple devices are connected to a bus. Okay, so what are the devices connected? CPU, memory, IO controller are common, connected to a common communication path. So here it leads to, if so already I have said, at the time it can do only one job. It can take only one, do only one communication. If more than one communication, it leads to confusion, overlapping, etc. So in order to manage this, we are going for bus arbitration. See, bus arbitration is the process of resolving conflicts that arises when multiple devices attempts to access the bus at the same time. So it resolves the conflict which arises when multiple devices want to do transfer at the same time. Okay, bus arbitration. So when multiple devices try to use the bus simultaneously, it can lead to data corruption or system instability. These are the disadvantages when multiple devices try to use the particular bus. Okay, so to prevent this, the bus arbitration mechanism is used. So, so my dear students, can you say now what is bus arbitration? Can you say what is bus arbitration? Can anyone say what is bus arbitration?
Ma'am, to ensure that only one device has access to any data time, ma'am.
What I didn't
Given
hear.
time, I mean. Ma'am, ensure.
Say any one of you answer.
Ma'am, bus arbitration mechanism is used to ensure that only one device has access to the bus at any time, at any given time.
No, not proper answer. Bus arbitration, what it does means it removes the conflict. Have you seen the definition? Once again, you see. Bus, can you see my slide?
Yes, ma'am.
So what it does means, 1 minute. Okay. So bus arbitration means it's a process of resolving conflicts. At a time, multiple devices want to use the bus. So bus arbitration, what it will do? It resolves the conflict that arise when multiple devices attempt to access the bus at the same time. Okay, it resolves the conflict that arise. So this is the proper definition. Bus arbitration is the process of resolving conflict that arise when multiple devices attempt to access the bus at the same time. So if multiple bus attempts to use the bus at multiple devices attempts to use the bus at the same time, what are the things will happen? It can lead to data corruption and data instability. So to prevent this, the bus arbitration mechanism is used. Okay, so there are several bus arbitration method. That is centralized, decentralized, distributed arbitration, bus arbitration. Okay, so what are the three types of bus arbitration methods? Centralized, decentralized, and distributed. Okay. So this already in the morning we studied. Okay, the bus is connected to processor, memory, and all the I/O devices. Then, so these are the three methods of bus arbitration: centralized, decentralized, and distributed. So centralized means it is a single device. It is called as the bus controller, which is responsible to manage all the device access to the bus. Okay, centralized means that's a bus controller. It is a single device which organizes which device want to use the bus at the particular time. Everything will be decided by the bus controller. That is the centralized arbitration. Then next is the decentralized. Decentralized means the devices uses the bus based on the priority level. Higher priority devices uses the bus first, lower priority devices uses the bus later. Okay, so decentralized means the devices are used based on their priority. The devices uses the bus based on their priority. Okay, last is the distributed. So in the distributed, what happens? Device complete for access to the bus by see. In the distributed, what is happening means the devices sends a request signal to the devices use the request signal to the particular controller or bus controller and waits for the grant signal. When it receives the grant signal, then it sends the data through the bus. Did you understand the three different types of methods? Centralized, decentralized, distribution. Did you understand the difference between the three methods? Did you understand the difference between three methods?
Yes, ma'am.
Okay. What are the, can anyone say what is centralized, decentralized, and distributed? So I will finish the class within 5 minutes, okay? Okay. So say the answer. What is the difference between centralized, decentralized, and distributed?
I mean, centralized a single device is used to manage the access, ma'am.
Very
Access to
good.
bus, ma'am.
Very good. Only Sanjay is answering my questions. Others sleeping. Girls side, you can answer. What is decentralized? What is distributed? So I've given, tomorrow in the class, I will conduct an exam regarding this topic. So as soon as I come inside, you have to take a paper and write everything, whatever I taught today. So it should be very effective, no? Simply others are going, only one is answering. Say what is decentralized and distributed.
Ma'am, decentralized device is for each device given as priority level, ma'am.
Yeah.
Highest priority will access the first.
Okay. Done. Okay. Tomorrow in the class we can see those. As soon as I come inside the class, you have to write about all these things which I taught today. Okay. So next we can study about the bus arbitration. What is bus arbitration? I have already said there is a thing that is the device which is controlling the overall performance of the bus system bus is called as the bus master. Okay, bus master. So the bus master, it will be the DMA or the processors. Okay, see. Okay. Okay, so bus master maybe DMA controller or the processors. Okay, these can be the bus masters. Okay, they resolve the conflict between the bus. They prioritize. The bus master, they will decide which device will use the bus now. Okay, that is the work of bus master. So here when we see a device that initiates the data transfer is considered as a bus master. So the bus master can be DMA controller or the processor. Okay, so these devices share the system bus, and when a current master bus, so this thing is what means the bus master decides which device to use the system bus. Okay, so there are certain applications of bus arbitration in computer organization: shared memory system, multi-processor system, input-output devices, real-time system. These are the application of bus arbitration. Embedded system, everything comes under bus arbitration. Real-time system, input-output devices, multi-processor system, shared memory system, everything else. Okay. So next we are going to study bus arbitration. We studied three methods, but bus arbitration has three methods. What are the three methods? Centralized, decentralized, then distributed. Here two approaches are there in bus arbitration: centralized bus arbitration, distributed bus arbitration. Though I have already said centralization means single bus takes decision. So single bus manages the system bus. Okay, single bus, that is the bus master or the bus controller, they will manage this one. Distributed means based on the priority. Okay, all devices participating in the selection of the next bus master. So first we are going to study about the centralized bus arbitration. Am I faster? Can you follow me?
Yes, ma'am.
Ma'am, you're not too fast, ma'am.
Okay, you're
follow.
able to understand.
Yes, ma'am.
Okay. So there are two approaches in bus arbitration, that is centralized bus arbitration, distributed bus arbitration. First, we are going to study about the centralized bus arbitration. This centralized bus arbitration, for bus arbitration, it uses three methods. Okay, three methods. One is the daisy chain method. So this is the method used for centralized bus arbitration. So first, it uses three methods. One is the daisy chain method. Another one is the Another one is the pooling or rotating priority method. Next, last one is the fixed priority or independent request method. After this, I will conclude the class. Okay, after explaining this, there is nothing. So daisy chain method. What does the daisy chain method means? See, it is a very simple and cheap method. Okay, all the bus masters uses the same line for making bus request. Okay, so all the bus masters we can say that is the DMA controller, then processor, then so bus masters means who initiates the job first, they becomes the bus master. Okay, so they will all will be in the same line requesting. The bus master, he analyzes this, so the bus master analyzes all the requests first, all the requests, and it selects which request came first. That device can use the bus first. Okay, so the request which came first, the bus master analyzes all the requests and it finds out who sent the request first. Okay, that device can use the bus first. So did you understand daisy chain method? So what it will do?
Yes, ma'am.
It will cancel, it will block the other bus grant signals. It will block and it makes the one particular device to use the bus. After that completion, the next request, okay, the next request will be, first request will be granted that signal to use the bus. So this is the thing here. Okay, so this is the thing. So bus request SAC, two signals are there. Okay, so the SAC means busy. Okay, so bus orbiter, the bus master, it analyzes the devices and it finds out. So it finds out this is the first device which sends the request first. Okay, so it grants that, so it blocks other requests and grants this request first to use the bus. So this is the daisy chain. The next one is the pooling or rotating priority method. What does this means? The bus manager, that bus master, he will find that bus master analyzes the request and gives the device which send the request first. But here, pooling or rotating priority method means it analyzes the request and gives the prioritized device first. It grants the request for, it grants the request. Okay, it grants the grant signal is given to the higher priority device. That is the rotating priority method. Okay, based on the priority, it gives the request. Did you understand? Yes or no? Pooling or rotating priority method?
Yes, ma'am.
Okay.
Ma'am.
Yes, ma'am.
Okay, next we can study about the fixed priority or independent request method. That means fixed. Each and every device, they are not based on priority. They are not based on anything else. For each and every device, if a device is sending a request to the bus orbiter, it immediately grants the request. See, in this, each master has a separate pair of bus requests. What is that pair of bus requests? Separate pair of bus requests. What are the bus request and bus grant? Okay, these are the separate pair of bus requests. It has a this method has a built-in priority decoder. Okay, this has a built-in priority decoder. So the bus orbiter, what it will do when it receives a request, it grants the signal. Okay, grant the signal, but based on the built-in priority decoder, it allocates the bus to use for the devices. Okay, so this also based on priority only. Higher prioritized devices is granted the first to use the bus. Okay, that's all about the three different methods. So any doubt? Any doubt whether I want to explain this topic once again?
No, ma'am.
So tomorrow in class you have to write this. Okay, so shall we wind up the class? If you have any doubt, you can ask. Otherwise, you can leave the class.
Thank you, ma'am.
Oh, okay, thank you. Thank you.
Thank you.
Thank you, ma'am.
Okay.
Thank you, ma'am.